As promised, this video is going to show the same problem, number 5, but instead of using the graphing calculator, we will just use algebra and get the exact height. So instead of having to estimate a height of 50, we're going to see how close that was. In order to do that, what we have to do is we're going to solve our first equation for t. So we're going to come up here, maybe I'll use fuchsia, and solve for t. So t is just x over 19, and we're going to come down here and we're going to say y1 equals h minus 4.9, and t squared becomes x over 19 squared. So again, we actually have three variables still, y1, h, and x. So what you can do in order to use algebra is pick a specific point in time that we know both the height and the horizontal distance. And that would be the end point where it lands. So what we know is that this height of 0 happens when x is 60 meters away. So 0 in for y and 60 in for x. We're going to run the numbers for 60 over 19 squared times 4.9, and you find that h is just 4.9 times that fraction squared. And plug it in your calculator and you get, exit out of this, and I already forgot, what was it, 16/18 squared times our gravity. Alright, looks like we should actually get 48.86, which is pretty darn close to 50, but if we wanted to be exact, height of the cliff to the nearest meter, I would accept on this problem either 49 or, based on trial and error, 50. And don't forget your units. So that's how you do the algebraic method. If you need the trial and error method, again, that was the separate video that we did using the graphing calculator, but this is just how you do it with numbers, no graphing calculator needed.